Okay, we are on chapter 11. We skipped 9 and 10 if you haven't noticed, because a couple reasons. One, because this chapter is just I think it's a little bit easier. Not everything is a little easier, but I think it's a little easier than what we've done before. Also, it's a little shorter too. It's only 5 lessons. I think the other one was like 7 lessons long or something like that. This is only 5. And I just thought it would be good to do this stuff. So here we go. What we're doing is something that should sound familiar to you. It should be something that you've done before, like in middle school or even elementary school. You probably talked about this, and that's finding the area of different polygons. Okay, now when you're a little kid, you probably didn't say the word polygon, but shape. Okay, the area of different shapes. All right, but in here, that's A-R-E-A. It's area. Okay, I said area. It kind of looks like it, doesn't it? It might not look exactly like it, but you knew what I was trying to write, didn't you? Okay. So we're trying to find the area of different subjects. Let's start off with a real basic one. This is probably the first one you learn when you're a kid, and this is one that is the first one you're going to learn in here. Okay, actually, let's do about like this. All right, so I have a rectangle. I'm telling you right now it's a rectangle, so we do have right angles right here, and we do have an area of this. Now, Blake said base times height, and that's actually what we're going to call that in a little bit. But right now, when you first learned how to do area, we had a formula for that. What was it, Javon? Well, what was the formula? What was the? So you probably learned when you were a kid the area of a rectangle is the length times the width, and that's fine. There's nothing wrong with that. Your teachers weren't wrong in teaching that. It's perfectly fine. But the thing is, we're going to change this a little bit. Instead of saying length and width, now that would have been the length, this would have been the width. And actually, it really didn't make any difference. You could have called this the width and this the length. As long as the two different sides, one was length and one was width, it didn't matter really which one was which. I remember as a kid thinking, oh, always the longest one's always the length and the shorter one's always the width. It really doesn't make any difference when you're trying to find the area of this thing. But instead of calling it the length and the width, we've talked about a couple words earlier in the year that we're going to use for some of these other figures. And that's called base and height. Do you remember that? We did a little bit of stuff with base and height. And who remembers the relationship between the base and the height? So if I talked about a base and I talked about the height had to be what to the base? Does anybody remember? No, not half. Anybody remember? I forget exactly where we talked about this. I think it was when we were talking about parallelograms. Remember that chapter? We talked about quadrilaterals. I think we talked about base and height when we talked about parallelograms. But the base has to be perpendicular to the height. All right. So when I talk about the base and the height have to be perpendicular to each other. It's true with length and width as well, but we're going to get away from using length times width, and we're going to call it base and height. Really, same exact thing. It's just our terminology is a little different. And somebody asked me in the last class, well, why do you want to do that? Because we're going to learn some formulas a little bit later that deal with base and height, and I don't want one formula having length and width, and then another formula talking about base and height. I like to keep it all the same. I think it's a little easier for us. So this is the area of a rectangle, which is the base times the height. So instead of length times width, we're going to call it base times height. This is a formula that you have to know. Right? This is the area of a what? What kind of figure is this? It's a rectangle. All right? So the area of a rectangle is the base times the height. If I wanted to draw another figure, watch this. What if I wanted to draw another figure that looked like this? What do you think that looks like? I know I don't have everything marked, but what do you think it looks like, just off the top of your head? A square, right? Okay, it's a square. It's perpendicular. All 4 sides are equal to each other. Some books and some teachers teach different formulas for this, but a square is the same thing as a rectangle. Do you remember that from that chapter on quadrilaterals? A square is a rectangle. It's just a rectangle with all 4 equal sides. So I'm going to figure out the area of this.
Can I grab my test?
Yeah. Alright, sorry I wasn't recording this, but I didn't get that far. So I've got a square, trying to find the area, base and height. So if I say it's a square, they're both the same, so 5 times 5 is 25. So that's 25. Alright, so that's the area of a square. You could think of it as just 5 squared if you wanted to, but just keep the same formula. Okay, I just think it's a lot easier to do it that way. I don't understand why people would even try to teach a different formula for a square as opposed to a rectangle, because it's really the same exact thing. Okay, enough of that. By the way, if this is 5 inches and this is 5 inches, what is the area? It's not just 25 inches, it's inches squared, because what's inches times inches? What's anything times itself? Something squared. So it's inches times inches is inches squared, so that's 25 inches squared. Okay, we good with that? Let's do another one. I'm going to still draw a rectangle again. I'm going to show you how we get this. All right, let's take a look at this. I've got a rectangle, and I'm going to put a diagonal in here. We've done that before when we did that chapter on parallelograms. We've done that before, right? So we know a lot of stuff about it. But let's just let's make this orange. Okay, watch this. I'm just going to talk about this part right here. So I started off with a rectangle, drew a diagonal, and what did I really draw? Two what? Two triangles. Okay. So let's take a look at this. If I call this the base of this rectangle, this would be the height of the rectangle, wouldn't it? Tell me something about the two triangles. I know I have two triangles here, but they are, let's give it a better word than equal, congruent to each other. Okay, these two triangles are congruent. I'll show you why. Because if this is a rectangle, if this is base, then what's the top going to be? It's going to be the base as well. This is height, this is what? Height. So that means that the two bases are the same, right? The two heights are the same. And they have right angles, don't they? So look what I have. Why are these two triangles congruent to each other? Side, angle, side. Very good. The triangles are congruent to each other because of side, angle, side. So we know they're both exactly the same. So what if I wanted to find the area of just the triangle and not the whole rectangle? It's just half of it. That's right. If those are both exactly the same, then one of these triangles is exactly half of the whole entire rectangle. Well, the whole entire rectangle, what's the area of the whole entire rectangle? Base times height. So what's the triangle then? That's right. Take half of it. So you could write it like this. You could put it over 2. Or you could write it another way. You could put 1/2 BH, or base times height. It means the same exact thing. Whatever your preference is, I don't really care. I use them both. Just depends. All right? But I can use them both. So that's why you get the area of a triangle is 1/2 the base times the height. When you're a kid, your teacher probably just told you, okay, this is the area of a triangle. It's base times height divided by 2, or 1/2 the base times the height. Especially in elementary school or middle school, sometimes teachers don't always go through why the area of a triangle is that. But now, do you see why I didn't use length times width? Because I used base times height, because we're used to seeing the area of a triangle using base and height. So I'm going to use the area of a rectangle as base and height. So you kind of get the idea. So we're just using the same words. Remember, the base and the height have to be what to each other? Perpendicular, not parallel, perpendicular. The base and the height have to be perpendicular, which means it has to form a right angle. Okay, that's very, very important, especially if we're going to do here in a second. Everybody with me? So that's the area of a triangle. How do you find the area of a triangle? Just take the base and the height. But remember, the triangle is half of a rectangle, so you take the base times the height and do what? Divide it by 2. That's right, or take half of it. Everybody got that? Pretty easy. Now, look at this triangle. I've got a right triangle right here. Look at the height. The height is actually part of that triangle, isn't it? Let's look at a couple triangles where the height is actually not one of the sides of the triangle. Alright, so let's draw a triangle. I'm going to purposely try to draw an acute triangle. Okay, that looks pretty cute, right? Alright, so that's an acute triangle right here. Now watch, if I call this, I'll tell you what, I'll make this a different color right here. Just make it green. Alright, what's that? Okay, you're showing me how to do that, right? Watch this. Actually, let's keep the same, let's do this. Let's say I call this side right here the base. Alright, so if that's the base, which one is the height? Is that the height right there? Or is that the height right there? Neither one of those are the height. Why not? Because the height has to be what to the base? It's got to be perpendicular to the base. I don't see any lines here that are perpendicular to the base. So what I have to do, let's do this in a different color. We'll do it in blue. Okay, yeah, we draw a straight line, but I don't want to just say a straight line. Look, I mean, that's a straight line, but is that the height? No, so we can't just say draw a straight line. We got to go from the top of the triangle, okay, or the opposite side of the base. Okay, the opposite angle of the base. And then, let's not say straight down, because that's a straight line and that's down, right? Let's be more geometric in our vocabulary. It's perpendicular. Okay, it's perpendicular. That's the word I want to hear. Okay, it's perpendicular. And that right there would be the height. Even though the height's not really one of the legs of the triangle, that's still what the height of that triangle is. So on an acute triangle, that's where it would be, right there. Everybody see that? What if I did this? Yeah, sometimes you put dotted lines. I have different colors, so I use different color, okay? Right, in books, sometimes you'll see a dotted line, and that's fine. Let's do this. I don't want to confuse you too much, but watch. Let's make this red. Looks kind of orangish, doesn't it? It looked red up there, but anyway, whatever color that is. Let's say that was the base. Oops. Let's say that was the base right there. Where would the height be to that one? Yeah, look at the opposite angle from here, and then it would be where? To here? To here? To here? To perpendicular. About there. And that, see that line right there, that red line? That would be the height if this was the base. You with me? Okay? Let me confuse you some more. What if that was our base?
The opposite angle of the perpendicular.
That's right. Go to the opposite angle and perpendicular to that yellow one, which would look about right there. Actually, these should actually line up like this. We've done this before, didn't we? Yeah. Didn't we do that before when we had that orthocenter and centroid and all that kind of stuff? Yeah. All right, so look. That right there would be the height. So that yellow one is the height to that base, that yellow base. Everybody see that? So that yellow height is the height to that yellow base. So you could do that all kinds of different ways. I think that's when we did that base height stuff, isn't it? Altitude, we talked about the altitude and all that kind of thing. Yeah. All right, so we did a right triangle, we did an acute triangle. What do you think is next? Obtuse triangle. So let's draw an obtuse triangle. And let's try to find the heights. Now sometimes, for some people, this is a little bit more difficult to see. It's a little bit different, a little bit more strange. Watch this. If I call this from here to here, if I called that the base, I got to figure out where the height is. Well, is the height this line right here? No. Is it this one right here? Send the baseline out. Right. So we extend it. Right. So if I can, I'll do a dotted line for this, just by hand. All right. So if we extend that base out, right, then I go, look, this is the angle that's opposite this base, isn't it? So I go up here. Now, I can't take it to there because that wouldn't be perpendicular. Going out here makes it even worse, doesn't it? So what I got to do is move it around until it's perpendicular, which would look about right there, wouldn't it? Even though it's outside the triangle, that's still the height. And this is still the base. This is what a lot of people do. Don't get mixed up. The base now is not from here all the way to where the height is, okay? This right here is still the base. Everybody watching that? So don't add this to this and say, oh, that whole thing's the base. It's not. From here to here is still the base. From here to here is the height. And again, how do you find the area of that triangle? It's the base times the height divided by 2. Alright? You okay with that? Tell you what, let's color code this again. We'll make this blue. Alright, so the two blues are the base and the heights. Is that alright? Let's code that too. Alright, so watch. That's the base and the height right there. The two blue ones, that's the base to that height. Agreed? Yes. Let's do this. Let's say that this right here was the base. So let's make that a different color. We'll make this one yellow again. And what would the height of this yellow one be? Well, again, what do? You look to the opposite angle, and then you have to draw it perpendicular, right? But the problem is, if I went from here, perpendicular, is that perpendicular? Is that up here? It's getting worse and worse. So what do I have to do? I'm going to have to come down here like this so that it's what? What do I have to do to that side right there? I got to extend it out, okay? It's where it would be, right, if it kept on going. So I got to take this. Now that right there is the height. Do you see it? Yellow base, yellow height. They don't have to touch, do they? Okay, but it does touch the extension. If I took this and extended it out, but still, this is the base, just from here to here. Everybody see that? From here to here is the base. So don't figure out the whole entire length from here all the way down to here. Just look at the side of the triangle. So this yellow is the base, and this yellow is the base. Let's do another one. Let's go with this pink color. And let's say that this side right here was that pink color. Okay. Where would the height of that be? Is that outside the triangle as well?
Yes.
No. Look at the opposite. Look at the angle that's opposite this side right here. It's this angle right here. Do you see it? So I start from here. Do I have to go outside the triangle to draw a perpendicular? No. It's right inside there, isn't it? Where does it look like? About right there? So look, that would be the height. So look, where's the base? The base is that whole entire pink line right there. And the height is this little one right here. So on an obtuse triangle, one height is inside the triangle. The other two heights are outside the triangle. Do you see that? On an acute triangle, all three heights are inside the triangle on an acute triangle. What about a right triangle? The height is where? It's actually part of the triangle. You could, if you wanted to, watch this. You could say, what if this was the base? What if we called this one right there the base? And, okay, we'll make that pink. Okay, what if that pink one right there was the base? Where is the height? From the opposite angle, where? Perpendicular, about right there, isn't it? Everybody see that? So on a right triangle, it depends which one is the base. If I called this the base, then this would be the height. If I called this the base, this one right here would be the height. If I called this hypotenuse the base, where would the height be? Right in here. That would actually be inside the triangle. All right? Okay, let's skip down past this. And let's see what we want to do. Let's do an example real quick here. So, oh, actually, I forgot about this. I forgot to do this in the last class. I was reminded after I had already recorded it. I'll tell you what, we'll just do this. I'll just draw just a regular acute triangle, nothing big deal. You guys watching? Let's say this was 5, this was 2, and this was, I don't know, 9. Is that all right? No, it can't be 9. You can't have it like that. Remember, if I add the two shorter ones, it has to be bigger than the third one. So let's make this 6. Is that all right? Okay, so we can have a triangle like that. They're going to ask you two things. They're going to throw another word in here. We've talked about this other word before. P for perimeter. That's right. Are you listening? It's going to ask you to find two things. It's going to say find the perimeter. The perimeter just means the distance around an object. Okay, and it's also going to say find the area. All right. Now, I don't know if these numbers are going to come out the way they're supposed to, but if that's 2, this is, I don't know. I'm just making stuff up here. Let's say it's 1.8. Is that all right? I don't know if that works according to these sides, but I'm just putting numbers in here. So what if they ask you to find the perimeter? How would you find the perimeter of a triangle that looks like this?
Add what all up?
Add what all up?
The outsides.
The outsides, right. All the lengths of the sides of the triangle. So it's 2 plus 5 plus 6. And what is that?
What happens if they don't give you
It's 13. Then you would have to find them. Okay? So they might not give you all the sides, and you may actually have to find it. We're going to actually do a problem real quick here to show you that. It's a good question. They may not give you all the sides. Right? What if they ask you to find the area of this? Yeah, this right here would be the what? That would be the base. And then if this was perpendicular, then this would be what? The height. Okay, remember, that's the height, that's the base, because they're perpendicular to each other. The 2 and the 5 cannot be the base and the height. Agreed? Because they're not perpendicular. But this is perpendicular to this. So what would you do? It's a triangle, so you got to put the half in there. Half the base times the height. And I don't care what that is. And that's the area of that triangle, whatever the number that is. Well, actually, half of 1.8 is what? 0.9. times 5, 45 carry 4.5. So the area would actually be 4.5 square, whatever it is. Let's call it centimeters. So the area would be that. All right? So that's how you would do something like that. So just make sure that you understand what we're talking about for perimeter. Now watch this. I'm going to give you a worksheet here in a second, but let me do number 1. Actually, they made usually like number 1's a little easier. They actually made this a little tough, I think. I don't think they're all going to be this difficult, so don't get too worked up over it. But this one does take a little bit of thought. It's not just a matter of them giving you the base and the height and just multiplying them together and take half of it. That's not all there is to it. Well, actually, for that part it is. Finding the perimeter is the hard part of this. All right, so what they're going to do is they drop this down. They make it a dotted line. They take this across like this. They make this one going up and down 12. This little dotted line is 10. This side of that triangle is 18. You guys writing this down? This is the problem. This is an exact problem. Number 1. It's number 1 of this worksheet I'm going to give you tonight. Okay, so I'm doing one of the problems for you, so you should be writing it down. And they're going to ask you to find 2 things. They're going to say find the perimeter, and then they're going to say find the area. All right, let's do the area first. The area is actually the easiest part of this. So what's the formula for area? 1/2 base times height. So let's see. Do we know the base and the height of this triangle? Well, I do know something that's perpendicular. So this is perpendicular to this extension right here, isn't it? So this would be the base, and then this right here would be the height. Everybody see that? Why is it the base and the height? Because it's perpendicular. Now, is it the whole entire 28? No, it's only the part of the triangle. Base is only part of the triangle. So the base would be, let's see, it's 1/2 times the base, which is 18, times the height, which is 12. So let's do this. Half of 18 is 9. 9 times 12 is, isn't that 108? Okay, so the area is 108. That wasn't hard. That was just plug and chug, wasn't it? You didn't have to figure out anything. All you had to do was look to see which one was the height, which one was the base, multiply them together, take half of it, bang, you got it. Use a calculator if you want. What's the other question they ask you? The perimeter. Now the perimeter is not quite as easy. Okay, now bear with me and watch what we're going to do here. I'm going to color these sides in so that we can refer to them. Look at the yellow side right there. Because if I find the perimeter, I got to add up all 3 sides, don't I? How many sides do I know right now of this triangle? Do I know 2? I only know 1, don't I? I only know this one right here, which is 18. I don't know this one. I made it yellow. And I don't know this long one right here. So I'm going to have to find both of those with the information that they've given us. Any ideas on how to find this yellow one? Or whatever. What's the name of it? Yeah, Pythagorean Theorem. Pythagorean. Named after a man named what? Pythagoras. Right, so it's Pythagorean. Some people say Pythagorean. I say Pythagorean. It doesn't make any difference. But that's what it is. Pythagorean Theorem. Now look. Look at this right here. How can we use Pythagorean Theorem? You can only use Pythagorean Theorem with what kind of triangles? With right triangles. So look what we're doing. We know this is 10 and we know this is 12. So we're going to find the yellow one using Pythagorean Theorem. Everybody with me? I'll call this one A and I'll call this one over here C when I'm getting ready to use it. Okay? So let's solve for A. So let's do it. A squared equals, right? That's the longest side, or the hypotenuse, squared, is equal to the 2 legs, 10 squared plus 12 squared.
I thought the hypotenuse was C.
It doesn't matter what letter you use. That's just what they use in the form. Okay, so let's do this. 10 squared, you should know that already. That's 100, right? Plus 12 squared, you should know that already. What's that? What's 12? 144 plus 100 is what? 244. Let's take the square root of that. So let's take the second function, square root of that, and that's about 15.6. All right, so A is 15.6. Why did I take the square root? Because I have to get rid of that squared right there. Do you see that? So that was the 2 44, so I got to take the square root of it, which gives you 15.6. So the length of that line is 15.6. So now I got two of them. I got the 18, I got the 15.6. What about this one right here? Let's color that. This pink one right here. So I got to find the length of that line. Any idea how to find the length of that?
Same thing.
Same thing, exactly right. But I got to look at a different triangle now, don't I? Look at the whole big triangle. See, this is a hypotenuse of this whole big triangle right here, isn't it? All right, so what are the two sides of this big triangle? And we'll call this C, all right? So I will go C squared equals, what is it? Yeah, 28. Where'd you get 28 from, Isaiah? 18 and 10, that's right. Because look, now I'm taking this thing right here. Even though this is an extension, this is part of that whole big right triangle, isn't it? So I got to take this whole side. So that whole side right here is 28. Everybody see that? All right, so I got to take, what, 28 squared plus, what's the other side? This one right here, which is 12 squared. Put them in a calculator, take the square root, and then I've got C. So let's do that. So I go 28 squared plus 12 squared, okay, equals, take the square root of that, the answer, and I get about 30 point, let's round it to one decimal place. What would that round to? 0.46. So what's the 6 do? 6 rounds to 4 up to a 5, so 30.5. Okay, so we'll say C equals 30.5. All right, and that's what that is right there. Now look what we have. There's one side, there's another, so what do we do to find the perimeter? Add them all up, that's right. So let's add them up. So it's 18, right, that one, plus 15.6, plus 30.5. Add those up, and that's what your answer is right there. I'll let you do that on your own. You can at least do that much, can't you? All right, what is it? 64.1? Okay. So that's the perimeter. Let's talk about the units. Now, I'm not going to be real picky in here about the units, but let's say it's in millimeters. So this is this just 108 millimeters? Now, this is area, so it's millimeters what? Squared. Okay. Now, this is perimeter. Now, perimeter is just a straight distance. It's not squared at all. So this is still millimeters, right? 18 millimeters plus 15.6 millimeters plus 30.5 millimeters. It's going to be millimeters. Those are your two answers. So they can get a little bit tricky. All right, we had to use Pythagorean Theorem. There may be some problems. Listen to me. There may be some problems that in order to find the height or even finding the base, you may, I'm not sure, I haven't done every single one of these problems and looked at them, but there's a possibility you might have to do some trig functions to be able to find the length of the height. They might give you an angle, they might give you another side, and you might have to use a trig function, sine, cosine, or tangent, to find the height. Or it might be a 30, 60, 90, right? And so what do you do? If it's 30, 60, 90, the hypotenuse is twice the short leg. The long leg is what? Square root of 3 times the short leg. They could give you a 45, 45, 90 triangle. What's true about that? The hypotenuse is the square root of 2 times one of the legs. So all that stuff that we learned before is not just going to be wasted, okay? We may rely on some of that stuff that we learned before, sine, cosine, and tangent. I really, really doubt they're going to make you use law of cosines or law of sines. Okay, I almost promise you that they won't. All right, but all that stuff we learned about right triangles are very important. Why are right triangles important? Because if that's the base and that's the height, look what I get. I got a right angle. When you get, excuse me, when you get right angles, you probably always have right triangles somewhere in there, don't you? All right, so all the stuff we learned about right triangles comes into play here. All right, so we're going to do a worksheet. There is a front and a back to this, so make sure you do both sides. And that'll be due tomorrow.